Hello, today we are going to be solving exponential and log problems. So we're going to be taking exponential problems and solving for x, or if an x is in the logarithm, we're going to be going from there. So let's start off with this first problem. If you want to pause the video and try these two out, you can, but I will be doing two more practice problems on the next slide as well. So the first thing we want to do is to isolate the log, which means that we need to subtract 12 from both of our sides, giving us negative log of 3 minus x equals 2. Now you may be thinking to yourself, what is the log base here, right? And we have the unwritten rule that if a log is without a base number, it is assumed to be base 10. So this is really log base 10, we're just not writing the 10 there. The next thing we need to do is get rid of this negative. So to do that, we're going to divide by negative 1. And that'll give me log base 10 of 3 minus x equals negative 2. Now we're going to undo the log, which means that we're going to change it into an exponential form. So this will give us 10 to the negative second equals 3 minus x. From here, we will get 1 over 100 equals 3 minus x. So we can say that it will be x equaling 2.99, or you could do 299 over 10 if you wanted, but that's being a little extra. Okay, for our next problem, similar concept. What we're going to do here is subtract 7 first, because again our job is to isolate the log. So we have 4 times log base 3 of 4x minus 1 equals 2. Now we're going to divide by 4. So this gives us log base 3 of 4x minus 1 equals 1 half. Again, 2 over 4 is 1 half. That should be pretty straightforward for people. Now we're going to undo our log. So we're going to change this from logarithm form to exponential form. So we have 3 to the 1 half equals 4x minus 1. Now, at this point, if you wanted to, I wouldn't blame you if you tried to round because, a lot of times with logs, we're dealing with irrational numbers anyways. But here I'm going to try to keep it without rounding. So I'm going to change this 3 to the 1 half. It's just the square root of 3, right? Anything to the 1 half power is the square root of that number. Positive square root because the inside, well, we have to have our log be positive inside. So we're going to just leave it as positive. So we're going to do a plus 1, and we get 4x equals 1 plus the square root of 3. And then our final step is to divide by 4. So x equals 1 plus the square root of 3 over 4. Now, you may think that's extra. If you did it with a calculator, you'd get about x equals 0.68-ish, roughly. Again, it's an irrational number. All right, so pause the video, try these two problems out, and when you're done, come on back. Well, hey, welcome back. Let's see if you got them right. Wow, the first one is x equals 5 over 2, or 2.5, and the second one is 5 plus the square root of 5, which if you got 5 plus the square root of 5, that would be the same as getting 7.24, roughly, 7.24. All right, if you got these two, move on to the next bit. If not, I'm going to explain it to you. So the first thing we want to do here is get rid of this 5. We don't have plus or minus our log on either side, so let's just divide that 5 out. So we get log base 2 of 2x plus 3 equals 3. So now undoing my log, changing it to exponential form, makes this 2 to the third power equals 2x plus 3. So I get 8 equals 2x plus 3. And then from here, I feel like it's a short hop and a skip to x equals 2.5 or 5 over 2. I don't think that's our issue. For the next problem, what we're going to do is now this time we have to subtract 7 first. So we get 1 equals 2 times the log base 5 of x minus 5. Now we divide by that coefficient of 2, both sides. So we get 1/2 equals, 1/2 equals, there, okay, sure, be extra. 1/2 equals log base 5 of x minus 5. So now again, undoing it, putting in exponential form, that's 5 to the 1/2 equals x minus 5. So that gets us x is equal to 5 plus the square root of 5, right? I just add 5 to both sides. Wow, wow. And there we go. All right, let's get to some good stuff. Not that that wasn't good stuff. I don't want logarithms feelings getting hurt, but I feel like this is a little bit easier to understand than doing it the other way. Okay, so now we're going from exponential to logarithmic. This is where logs really come in handy. What you're essentially trying to do here is deal with the fact that this is not an easy thing for us to solve. Most of these are going to be irrational numbers. So our goal here is to get this exponent, and we're going to try to put that out front of a log. Now remember this rule here. If we have log base a, meaning that the log base can be anything as long as it's not going to be, it's positive and it is, let's see what else. Yeah, positive and not, can't be 0. So log base a of b to the x is equal to x times the quantity of log base a of b. This rule is crucial. You can take this exponent and bring it out front, and now it's x times that entire quantity. And again, I use a, b, and x. These are all just variables. You could use whatever variable you want, but this is a rule in regards to log. We'll talk about this more in future lessons, why this has to hold true. But you can simply do a mathematical analysis to try to plug numbers in, right? So like if you did log base 10 of 9, that's the same thing as log base 10 of 3 squared, which is equal to, it's equal to 2 logs of 3. If you put both of these in here, these will be equivalent. You can do a real quick, easy check on that in the old click-clack machine and solve that that's true. So we're going to take that rule and we're going to expand upon it. We're going to take the log of both sides. Now, if you don't have a fancy calculator that lets you do log base, that's a whole other thing. We'll have to do a different way to do that. But for here, we're going to assume that you can do log base, not n or e. So because this is a 7 to the exponent, we're going to take log base 7. If this were any other number, we always take log base that number. So we'll take log base 7 of 7 to the x plus 2, and that equals log base 7 of 12. So I'm essentially taking log base of both sides. And you can do this at any time, but it makes sense for us to do it here. The reason we picked log base 7 is because if I take log base 7 of 7, I will get 1. Log base b of b is always 1 as long as b follows the standard rules of what you're allowed to have for a log base. So the next thing we're going to do is we're going to this is going to be x plus 2 times log base 7 of 7 equals log base 7 of 12. Now, as we stated already, this is 1. And because this quantity is 1 here, we're just left with x plus 2 equals log base 7 of 12. So now what I can do is I can subtract 2 from both sides and get x equals log base 7 of 12, that whole thing, minus 2. Okay? And you can put that in the click-clack machine and get an actual, well, not an actual number, but get a decimal representation out. But I always love a good irrational number. Okay, so that's one way we can do it. Let me show you the other way real quick. If you don't want to look at it, that's fine. It's your right as a person in this class. You can not look at this other way. But this helps if you do not have able to do a log different base. Okay, so what I would do instead is, this is again assuming you can't do logs of different bases, I would just do log base 10 of both sides. So I do log base 10 of x plus, or log base 10 of 7 to the x plus 2 equals log base 10 of 12. I can still take this x plus 2 outside, but now the only difference is this log base 10 of 7 does not reduce to 1. It's going to be some other irrational number that I don't know. So I'm going to divide both sides by log base 10 of 7. So I get x plus 2 equals log base 10 of 12 over log base 10 of 7. Now, let me tell you something. These logs do not cancel out. You can't just do log over log and be like, oh, look, the L's and the O's and the G's cancel out. That's not mathematically correct. That's not how that works. So we just leave it like that, and then we get x equals log base 12, or log base 10 of 12 over log base 10 of 7 minus 2 would be your answer. And if you did the first problem, oh my goodness, you do that first problem and the second problem, you get that they're the exact same. Okay, let's try out number 2 here. My only difference in this problem is I want to subtract 3 from both sides first. So I get 7 equals 5 to the 2x minus 3. Now, again, because this is a 5, I'm going to do log base 5 because log base b of b is 1. So we want to try to cancel it out. So I'll take log base 5 of 7 equals log base 5 of 5 to the 2x minus 3. And now what I can do is I can bring this whole exponent out front. So this is log base 5 of 7 equals 2x minus 3 times log base 5 of 5. Well, as stated, I think for the third time now, this will reduce down to 1. So I get 2x minus 3 equals log base 5 of 7. So we just do a little bit of quick work. Let's add the 3 over, and then let's divide by 2. And this equals x. And again, if you want to do a decimal approximation, you can. All right, here's 2 problems for you to try out. So pause the video, try these out, come on back when you're done. Again, remember, round to the nearest hundredth here. It's just easier than me writing out the complicated log. Well, hey, welcome back. For the first one, I got my marker to write on it. I got 1.12 and then 0.64. So if you got those two, congratulations. You leave, you get out of here, you go home. Well, you don't go home, you stay home. But if not, let's do a little explanation. So the first thing we want to do here is see this 8. We'll take log base 8. So log base 8 of 8 to the 3 minus x equals log base 8 of 50. We're going to bring this around the outside. And now we have 3 minus x equals log base 8 of 8 equals log base 8 of 50. Whoop. All right, next, this will cancel, and we'll be left with 3 minus x equals log base 8 of 50. So now we're going to subtract 3 over log base 8 of 50 minus 3 equals a negative x. And then we're just going to divide by that negative. So x will equal a negative log base 8 of 50 plus 3. And there you go. That's the approximation there. Now, if you look, you say, oh, look, that's 1.12. Does that make sense to us? Well, let's think about it. We want it to be a little less than, uh, we want the power to be a little less than 2, because if it is equal to 2, then 8 squared would be 64. So we know it's got to be less than 2, this exponent. So 3 minus 1.12, that makes sense to us mathematically. We know it has to be a little less. All right, next problem. Okay, I'm going to subtract 7 first, so we get 48. That's not how that works. We get 49 equals 12 to the 4x minus 1. Now we'll take log base 12 here. So we get log base 12 of 12 to the 4x minus 1 equals log base 12 of 49. And then what we're going to do is we're going to subtract, sorry, we're going to bring our exponent out front. Log base 12 of 12 equals log base 12 of 49. Now this will simplify to 1. And we get 4x minus 1 equals log base 12 of 49. You add 1. Whoop, look, that's zero. That's not 0, it's an O. Okay, let's try it again. We try and we get log base 12 of 49 plus 1 divided by 4. And that equals x. All right. Hey, thank you for watching the video. If you got any questions, either comment on here or send me a quick email and I will get right back to you. Hope this helps and gave you a little bit of further explanation, further practice on solving logs and exponential problems. Have a good one.